Okay, so a smart contract can only be interacted with by sending a transaction. But you might have realized that the whole thing is anything but efficient. Not only is the smart contract execution happening on every single node in the Ethereum network, but also whenever you store, for example, a single number in a smart contract, this number will be stored on every single node in the Ethereum network. It would be incredibly easy to make the Ethereum network unusable by storing lots of data and bloating the required storage space for nodes. And also, what would happen if our smart contract execution had an infinite loop? It would completely hang the network. All of this is actually another reason for why the Ethereum Virtual Machine exists. And it all has to do with gas. Gas. That's right. And indeed, quite similar to what you would get at a petrol station. It's the fuel for the Ethereum network. Every transaction needs it to run, like a car needs petrol. Each opcode in the Ethereum Virtual Machine has a gas cost attached to it. Most of them are fairly cheap, but some, in particular reading and writing smart contract states, are more expensive. Here on the evm.codes website is a great overview of all opcodes and their gas costs. You can see here most of them are fairly cheap, but some are more expensive. And in particular, the opcodes that are reading or writing to permanent state are more expensive. Especially storing new data is expensive, because now this data has to be stored in every node, taking up hard drive storage. Now, when running a smart contract with an infinite loop, eventually it would run out of gas. Just like a car driving infinitely in a circle would eventually stop because the tank is empty. And if you want to store data, it will cost you a lot of gas. So it would be very expensive for you to bloat the Ethereum network. Nice. So how do we get this gas? You can get the gas by using Ether. So how much gas do you get for 1 Ether? That depends on the transaction. You can configure this conversion rate by setting a so-called gas price. The higher the gas price, the more likely miners are to include your transaction in a new block. So you see here, the gas prices are fluctuating from day to day. The more transactions people are sending, the higher the gas prices will be. And you usually denote gas prices in gwei, which stands for O and then 8 zeros, 1 Ether. So quite a small amount of Ether. But remember, this is what we pay per single gas unit used by the transaction. So for example, you have a gas price of 100 gwei and your transaction costs 21,000 gas. This is, by the way, the smallest gas cost any transaction can have in Ethereum. And now the cost in Ether would be gas used times gas price. So in our case here, in total 0.0021 Ether. And then you can convert this to US dollar or any other currency you want to figure out how much the transaction is costing you. And so why are the gas prices fluctuating? Because the miners are the ones actually receiving the transaction fee. So of course they are going to prioritize higher gas prices to get more Ether. Setting an extremely high gas price, miners will immediately try to include it in a new block. Setting an extremely low gas price, miners will just ignore the transaction. Actually, at least it used to always be like this, up until the Ethereum network upgrade called London. This upgrade included a new transaction type, which introduced a new gas price mechanism known as EIP 1559. Instead of sending the transaction fees to the miners, they are simply burned. And a baseline for the gas prices in a given time is calculated by the network itself based on demand. This gives users a better guarantee on what to set as gas price for their transaction to actually be included in the blockchain, rather than randomly guessing one and hoping the transaction will make it through. So since the Ethereum will be burned, it could actually mean that Ether as a currency becomes deflationary, as long as the burned amount for fees is greater than the newly minted tokens from proof of stake.